Okay, now class, we will now discuss yung shear and moment functions nung beam natin. So, right after we identified or have determined how to calculate yung internal forces natin into a particular point, ngayon consider natin yung shear and moment values natin, yung internal forces natin in terms of X na siya. No? So, ibig sabihin, kailangan ma-identify natin yung equation para any point dun sa beam natin, kaya nating ma-identify o malaman yung value ng internal forces natin without even um, cutting a section ulit ng ilang beses para ma-identify lang natin yung forces natin. Okay? So, yun yung consider natin for today. And for our outline, we have yung shear and moment functions of beams and then procedure for analysis. And then we have solve problems to demonstrate kung paano ginagawa yung in terms of X, yung values natin. Then learning outcome natin for today will be the following. So to calculate yung shear and moment function ng beam between applied discontinuities natin. And then last is to solve for the shear and moment values between specified region natin. Or in terms siya ng function na siya o equation na yung answers natin. Okay, so let's start. So beams are structural members which carry lateral loading, or in short, yung beams natin are yung main function niya is to carry mga perpendicular forces sa kanya. So let's say itong diagram natin na ginagamit dito sa taas, we have a beam. So usually ang load na kinoconsider natin sa kanya is yung naka-perpendicular sa axis niya. So, di ba ito yung main axis ng beam natin? Ito yung cross-section niya. Pag tinignan natin doon sa elevation na yon o sa cross-section, ito yung axis na yon. And ang kinoconsider natin sa kanya is lahat ng applied dito sa axis niya, which is perpendicular dun sa mismong length niya. Okay? Kaya, ayun yung usually kinoconsider natin as forces na acting sa beam. Okay? And the design of a beam requires detailed knowledge dun sa internal forces ng shear and moment natin o kung paano siya nagbabago. Kasi ang shear and moment natin, internal forces natin, nagbabago siya depende kung saan naka-apply yung load natin. Let's say for example, itong beam na to. Ibig sabihin kapag nag-calculate tayo ng internal forces dito sa point na to, halimbawa, the value on this point is different dito sa point na to kasi dito meron siyang applied na distributed load o rectangular load sa kanya. And dito wala siyang naka-apply na loading. So definitely the value of shear and moment will be different. So ngayon, ang kino-consider na natin i-calculate ngayon is for the whole beam. So we need to get a representative equation para ma-identify natin any value ng internal moment and shear dun sa beam natin. And mapapansin nyo, typically, axial forces are not considered kasi if you have observed yung mga previous discussion natin kung paano kunin yung internal forces, laging equal to 0 yung axial force natin. Kasi si beam is generally designed siya kapag dun sa mga perpendicular perpendicular loadings natin. So, may nag-a-act syempre na normal force pero with comparing that to the value of the shear force and moment natin, it is actually very negligible na yung value kung i-compare natin by scale, no? Kaya typically, axial force is not considered kasi si beam is loaded perpendicularly in most cases. And then, yung resistance ni beam to shear and bending are more important than the axial resistance. Kasi nga, hindi naman natin niluloadan si beam lagi. Or si beam are used to carry loads perpendicular to its axis, no? Okay. So the variation of the shear and moment along the beam may be written as a function of x of the position or as a function of x o yung position niya. Okay? So generally, inaano natin siya, nilolocate natin siya from the outermost leftmost na reaction, no? So usually ang practice from left to right. Okay? Kaya lagi ang origin or ang reference is yung x natin, yung left support natin, yung A natin. Okay? Then from that, nagka-cut tayo ng section. So bakit kailangan mag-cut ng section? Kasi yung mga points usually na given sa problem are points or boundary kung saan nagkakamero ng change or applied load. Okay? Kaya dito, kung halimbawa gusto natin makuha yung internal reaction between A and B, okay? Kailangan doon tayo mag-cut ng section. So, ibig sabihin, any distance mula sa A papunta sa left ni B, okay, are all considered by a single formula kapag nag-cut tayo doon. So, halimbawa, nag-cut, ito yung kinonsider nating segment, no? And then, ano tayo, may nakuha tayong equation for shear tsaka moment na in terms ng x. Ibig sabihin, kung halimbawa, ang distance ng A to B ay 5 meters, kung halimbawa pinahanap sa problem, ano yung distance ng 1.5, ano yung value ng 2.0, ano yung sa 2.75, without even um, going dun sa normal process natin na nagkakat tayo ng section na 1.5 yung length, 2.0 yung length, 2.75 yung length. Ngayon, isang formula na lang yung gagamitin natin. And then, gagawin lang natin, isa-substitute lang natin yung value ng 1.5 ng 2.0 at ng 2.75 dun sa equation na makukuha natin. Okay? And then, again, every segment, maggagawa tayo ng sariling formula niya. Ibig sabihin, itong segment na to, kapag nag-reference tayo ng x sa kanya, ibig sabihin yung formula makukuha natin is for the segment B to C only applicable. Okay? Kasi yun yung makukuha nating formula sa kanya. And then dito, kapag dito tayo nag-cut, ibig sabihin segment C to D lang yung maka-calculate nating value. Okay? So, here is the procedure for analysis kung paano daw natin i-calculate. Kukunin yung equation in terms ng x tsaka ng in terms ng x ng shear at ng moment natin. So yung first one of course is to determine yung support reactions natin. Actually, the same procedure applies, no? Parang same procedure nung ginagawa natin before. Pero ngayon, yung imbis na mayroon tayong value ng length o ng point no na value, x lang yung ilalagay natin. So yung first one is nagde-determine tayo ng support reaction. Next is specify natin yung coordinate x. So meaning yung mula doon sa pinakadulong support hanggang doon sa cut section natin, yun yung tatawagin nating x. And then kung may mga applied loads in between niya o yung kasama sa kanya, ima-minus na lang natin yung mga distances niya. And next is section natin yung beam perpendicular to axis. So, nag-cut na nga tayo ng section. And then determine natin yung shear and moment natin at the cut section using yung sign convention natin na ginamit natin na dapat lagi yung normal force natin is tensile dapat siya, and then yung shear force natin dapat magkakos ng clockwise rotation. Then si moment dapat mag-cause ng curvature upward or ng lift dun sa beam natin. And then to check daw kung tama yung result natin, gagamit tayo ng derivative, no? So dito na yung mga nagka-question kung para saan ba pinag-aaralan yung derivative. So dito natin siya pwedeng magamit, no? So dapat daw yung pag dinerive natin yung equation na nakuha natin for moment, dapat equal siya dun sa shear natin. And kapag dinerive daw natin yung sa shear natin, dapat ang makuha natin ay equal dun sa value ng loading natin dun sa beam natin. Okay? So to make sense dito sa lahat ng procedure na nakalagay na to, i-apply natin sa example beam na to. So we have this fixed beam applied with a 4 kips per feet na rectangular loading at 0 hanggang 12 feet nung length niya from A. And then meron tayong applied load dun sa end niya, dun sa overhanging end niya na 60 kip tsaka 100 kip per foot. Kip foot na moment. Okay? So, ngayon lagyan ko lang siya ng designation. No? Lagyan ko siya ng A, B, and ito ay yung C natin. Okay? So, meaning, yan yung mga gagawin natin cutting segment. No? Kumbaga, kung saan may change ng loading, doon kayo maglagay ng point. Okay? Kasi yun yung kukonsider natin later on. Okay? So dito, nakapag-produce tayo ng dalawang segment. Segment A to B, okay, and segment B to C. Okay? Yung segment A to B natin, yung distance niya will be from 0 less than equal x less than equal b. So, ibig lang niyang sabihin, is any distance mula dito sa 0 natin o dun sa pinaka-leftmost, ito yung consider natin 0, and then hanggang dito siya sa 12. Okay? So, yun yung segment AB natin. And then for segment B to C, that will be yung distance natin from 12, lagyan na natin 12 to, no? Kasi 12 feet yung nakalagay. So 12 less than or equal to x less than or equal to yung total natin na 20. Okay? So ibig sabihin yung segment BC natin, itong next segment na i-cut natin, that will be applicable dito sa distances na to. Okay? So, so let's do na yung ating solution sa kanya. Okay? So ito is paliitin ko lang, no? Para hindi siya masyado sagabal sa atin. Okay? Yung first one is calculate natin yung support reaction. So, hindi gagawin natin, kailangan natin ng free body diagram tayo. Okay? So, we have here yung ating beam. Okay? And then, as support reaction, we have a fixed beam. So, tatlong reaction yan, no? So, we have yung AY, AX, and moment at A. And then, applied loadings natin, wala na tayong ibang reaction, no? So, meron tayong applied loading na 60 kips dito. Then, we have a moment na 100 kip foot. Then, meron tayong rectangular. So, kailangan natin ng ECL. So, ECL natin will be 4 kips times yung 12 na length niya. So, 48 kips. So, that is equal dito. Okay? So, 48 kips na ang distance niya, consider na natin dito. So, ito yung half nung 12. So, 6.0. Then, yung total natin is 20. So, definitely, this length will be equals to 14.0. Okay? So, calculate natin yung ating support reaction. So, summation of moment at A is equals to 0. Taking count clockwise as positive. So, we have yung M natin is clockwise siya. So, MA, counterclockwise siya. So, negative siya. Plus 48 times 6 plus 60 times 20. Then, plus 100 is equals to 0. So, calculate lang natin. So, 48 times 6 plus 60 times 20 plus 100. Our moment is 1588 feet. Okay? Yun yung value natin. Next is we have yung summation of forces x equals to 0. So, wala tayong ibang other forces. So, AX lang yung value natin for that. Okay? Next, summation of moment. Papunta naman tayo kay C is equals to 0. Taking counterclockwise as positive. So, alin magro-rotate lang natin? Si 48, si AY, si MA, tsaka si 100 yung magro-rotate natin. So, we have here summation of moment. So, si MA positive, si AY will be negative times 20 plus 48 times 14, and then we have counterclockwise 100 is equals to 0. So, pwedeng si MA ilagay na natin yung value, no, na 1588. Okay? So, AY natin upon calculating. So, 1588 plus 48 times 14 minus 100. Tapos, divide natin by 20. That is 108 kips. Okay? So, checking tayo, summation of Fy is equals to 0. So, we have Ay minus 48 minus 60 is equals to 0. So, that is 108 minus 48 minus 60 is equals to 0. Therefore, 0 is equals to 0, which is correct. So, ibig sabihin, yung support reactions calculated natin are indeed the correct value for the given beam. Okay. So now, we can now consider yung ating segments, no? Again, ang segment natin will be ito, yung unang segment natin. So, gawin ko lang cut AA, no? Consider natin is yung left side niya. And then, ito, gawin natin cut BB. Okay? So, consider natin muna yung AA. So, we have AA. So, kailangan drawing nyo yung cut AA. So, we have yung beam natin. So, same lang nung ginagawa natin, no? Nag-cut lang tayo ng section. So, ngayon, ito yung section natin na yun. Then, may nakalculate tayong values. So, ito yung 108. And then, we have 1.5. Sorry, this is not shear. This is moment. Okay? Yung shear, kahit di na natin ilagay, no? Kasi wala mo siyang value. Then, we have a rectangular load na meron siyang 4 kips per foot. Okay? So, pag nag-cut kayo ng section, imbis na maglagay tayo ng specific na distance, ngayon, ito, kung consider natin siya, mula doon sa cut section natin, this will be our x function. Okay? So, meaning, pag kinuha natin yung ECL natin, ECL, nung rectangular load natin, that will be 4 times x, or yan yung ating magiging value ng ECL natin, which is applied dito. So, yan yung 4x natin. And yung distance niya dito will be, since rectangular yan, half nung ating x or 0.5x tayo. Okay? And then expose natin yung lahat ng forces natin. So, si normal force kahit hindi na natin lagay kasi hindi na natin kakalculate. And then we have shear and moment. So, yung shear natin, again, kailangan mag-clockwise direction. Kaya downward yung ating assumption. And then si moment, kailangan i-lift niyo yung beam pataas na ganun. So, yung moment natin should be like this one. Okay? So, calculate lang natin. Summation of forces y is equals to 0. So, wala naman nagbago, no? Same lang din in terms of x lang yung value natin. So, we have 108 minus 4x minus v is equals to 0. O yung v natin is equals to 108 minus 4x. So, this will be our equation for shear. Okay? The next, moment. Summation of moment. Tawagin natin itong S ulit. S is equals to 0, taking counterclockwise as positive. So we have yung 1588 natin will be counterclockwise. Plus yung 4x, magro-rotate siya ng 0.5x. And then yung 108 natin, so 108 clockwise siya. So 108 times x. Then yung moment natin, m is equals to 0. So arrange lang natin. Si m, lipat natin. And then combine natin yung pwede i-combine. So dito, I think wala nang pwede i-combine, no? Plus 2x squared minus 108x. Okay? So this will be our moment equation. Meaning, dun sa segment AB natin, wherein yung distance natin is 0, less than x, less than 12. Ibig sabihin, any point na i-consider natin dito, halimbawa itong point na to, halimbawa 8 meters mula doon sa support natin, ito lang yung gagamitin nating equation sa kanya para makalculate natin yung value. Okay? So, any value ng x basta within dito sa range na to, ito na makukuha na natin yung value ng v at m niya without even cutting every point na i-consider natin. Okay? So, ito na yung mga steps natin. Ang kasunod na lang is to check kung yung derivative ng moment, sabi, kailangan i-check natin if yung derivative daw ng moment with respect to x ay equals to dun sa ano natin, sa shear natin. So, going back to your differential equation, no? A differential calculus, rather. So, derivative ng constant will be 0. This will be 2 times 2. X2 minus 1 times 1. So, derivative ng power or power rule na tinatawag minus 108 times 1 x1 minus 1 times 1. Okay? So, simplify. We have 4x. Tapos ito will be x raised to 0. So, that will be also equals to 1. So, minus 108. So, is it equal to our value? Ito, dito. So, magkaiba siya ng sign, no? So, let's check kung tama yung sign ko dito. Ayan. So, kaya ako na mali dapat this should be positive, no? So dapat lahat ito is reverse ng sign. Dapat ito will be negative, this will be negative, and then this will be positive. Okay? So upon derivative, this will be negative, and this will be positive. So ito is negative, ito ay positive. Okay? So now, is this equal now do sa velocity, do sa shear natin? Yes, no? So negative 4, x plus 108. So same siya ng shear natin. Okay? And then kapag chinek daw natin si derivative ni shear natin with respect to x, dapat equal siya dun sa ating loading. So check natin. So dv over dx natin. So derivative ng constant will be 0 minus 4 times 1 x 1 minus 1 times 1. Okay? So negative 4. Sabihin negative 4 dapat. So dapat downward na loading na 4 yung value natin, which is indeed a beam na negative 4 downward yung ating value. So this is our answer. So ibig sabihin correct siya. Okay? So yan yung para sa first segment natin na AA. Okay? Next is yung segment BB natin. So sa segment BB, okay, again, applicable siya para sa distances na 12 less than equal x less than equal sa 20 natin. Okay? Dun sa ano natin ng segment, no? Don't forget, kailangan bawa yung segment B na tayo, dapat kasama yung buong segment na to. Okay? So, okay, so let's try to calculate that. So, ito yung segment natin. So, ito yung B natin. So, much longer na siya, no? Then, ito yung cut natin. And then, makikita nyo, pumasok na yung ating rectangular force doon, no? So, ito yun. Okay? So, ayan. And then, ano yung forces natin? We have ito, 108. Then, meron tayong 1588. Ano pa yung applied natin within that? Ano? Wala, no? Ito lang, no? Itong 4 tips lang natin. 4, 4K per foot. May distance tayo dyan na 12 hanggang dito, no? Pero dapat, again, from hanggang leftmost hanggang sa cut section natin, tatawagin natin siyang X. Okay? So, ibig sabihin, pag kinuha natin yung ECL natin ngayon will be 4 times 12 kasi kasama na siya lahat, no? So, 48 kips. So, ito yan. So, 48 kips. And then, yung distance niya will be how much? Okay? So, di ba, yan ay half sa half. So, ibig sabihin 6 to. So, yung distance na yun, yung kabila, is x minus 6. Okay? So, yun yung ita-travel niya pag nag-moment na tayo. Okay? Then, i-expose lang natin yung mga forces natin. Normal force, hindi nakasama. So, si shear is magka-clockwise and then si moment is magte-tend na i-lift pataas yung ating. Okay? Then, summation of forces y is equals to 0, taking upward as positive. We have 108 minus 48 minus v natin. Okay? Okay, is equals to 0. So, v is equals to 60 kips. No? So, wala siyang value ng x. So, ibig sabihin, dito sa segment na to, okay, dito sa whole segment na to, do sa range natin, ibig sabihin, constant yung value ng shear natin. Na 60 lang siya. Okay? So, any point dyan, 60 lang lagi yung makukuha natin. Kasi makikita nyo, wala siyang loading sa gitna niya. Okay? Eh, di ba yung range na yan lang yung pinag-uusapan natin. Next is yung moment. Summation of moment. S is equals to 0. Tawagin ko tong S. Taking counterclockwise as positive. We have 1588 minus yung 108 natin times x plus 48 times x minus 6, and then plus m is equals to 0. So since positive yung m, transpose natin lahat to the other side. So this will be negative 1588 plus 108x minus 48x minus 6. So pwede natin simplify 1588 plus 108x minus 48x plus 6 times 48, that is 288. So combine natin yung like terms. So we have 100x, hindi pala 100, 60x, 60x, then negative 1588 plus yung answer natin, that is minus 1,300. So that is our moment function. Okay? So to check, kunin lang natin yung derivative. So derivative ng moment with respect to x. So that is first term natin, 60 times 1, x1 minus 1 times 1. And then derivative ng constant ay 0. So this is equal to 60, which should be equal dun sa shear natin, which is correct. Okay? And then we get yung derivative ng ating shear. So derivative ng shear natin with respect to x should be equals to dun sa loading natin. So derivative of v with respect to x, since constant yon, that will be equal to 0, which is dito sa segment natin na yon, sa range natin na yon, is wala siyang applied na loading. So ibig sabihin 0 yung loading niya, which is correct. Therefore, yung calculated values natin for formula ng shear and moment are correct. So ibig sabihin pwede na to dun sa ating segment na to and then sa segment na to. Okay? Pero iba yung usapan kapag point C yung pinag-uusapan natin dito. Okay? Kapag point C, i-consider na natin yung applied load sa kanya. So, dapat yung shear natin doon will be 0 kasi magma-minus 60 tayo. And then yung moment natin, kung ano man yung value ng moment na calculate natin, minus ito, this should be also equal to 0. Na on our next discussion, i-discuss natin yung pag-plot niya. Okay? Pero before that, do you have any clarification or question dito? So, ganito po yung solution niya with respect to x. So, almost the same procedure lang, nagkamero lang tayo ng variable na x, no? Okay? So, I think the other example, hindi na naabot sa oras, no? So, I want you to try to get yung function nito with respect to x and also the other example. Pero I will try to make a discussion, a recorded discussion for that para may reference din kayo. Okay? Pero if you don't have any more question for the lecture natin, this ends our lecture for today.